Yeah, hi everyone. Welcome to Pandas 5. So today we'll look at all of this. This is the agenda. It is a bit heavy, but these are we can go through them pretty quickly. So we'll just uh, melt and pivot some data, the medical data that we have looked at in the previous class, and then we'll be operating on this data as much as possible if it is convenient, and then we'll look at none versus nan. Nan is not a number. This is a numpy value, float value. So basically, this is dealing with missing data. So if you have like blanks in your tables, or if something is missing, then by default Python uses none, and NumPy likes to default to nan, although interoperability is there, but still nan is more performant, so we'll be looking at that stuff. So all of the none versus nan behavior, and then we'll look at how to detect none values. So we use isNA, then there is something called isNull. Both are same. IsNull and isNA, they are just different. It's just different syntax. Both are essentially the same. Then we can check how many null values are there using the sum, by calling the sum method on the isNA value. So isNA and isNull, they give Boolean lists. So we do a sum and then get the number of missing values in that. We can do it row wise and column wise using the access argument. Then we'll be looking at, let's see, basically how can we handle the null values. So if we know what null values look like, right? And then we know how to find how many of them are there and how to find the missing values. And now we want to know how we can handle these missing values. Like, should we delete them, or should we add some other value in those empty fields so that we don't see any missing values, or should we just drop that entire column because there's just too many missing values? Because it doesn't make much sense to deal with data where a large proportion of values are missing. So that'll all come under handling null values. Then we'll look at string methods. So we don't need to know all this, but these are really convenient methods, and I haven't listed all of them. These are just some of them, and it's just good to have them in mind, what on a very high level what they do, right? So we have on case conversion, if you want to convert it from uppercase to lowercase and vice versa, and you want to remove or filter some characters, right? Then you can search for some characters. If you want to replace you have, suppose you have a name Rahul, and then you want to replace the HUL with maybe some RA, whatever name that you want, you can do a replace. And then there is a translate method also, which is like a cipher substitution, like a key basically what translate does is it allows you to create a mapping of certain set of characters with the characters that you want. It's like if you have a cipher, suppose you have a cryptic string, like a code, and that code will only make sense if you have a proper key where each letter is mapped to a different letter. So you want to replace that with those keys, then this can be quite useful. Then Splitting and joining, again you can split the string at certain, like at spaces, or maybe after commas, or maybe after colons, or maybe after semicolons, and then you can join them back again at particular with these particular delimiters. And then some regular expression stuff, basically sophisticated ways of extracting or finding if a string exists. Like suppose you have something like a phone number like 999999888, something like that, and you want to know if all the numbers have this exact pattern. So you can give some sophisticated it's like custom string operations. We won't go too much into depth because I'll cover regular expressions in detail in the Python section. We'll just look at very, very high level stuff here. Then character test, we can check if it is an alphanumeric or just a numeric value, or if it has only spaces, or if it is an uppercase string, lowercase string, title case string, all that stuff. And then encoding, decoding, again this I will take a separate class for this, because I think this is quite useful when you are dealing with essentially web script data, like because we have data in different formats, right? We have different languages, we have emojis, there's like a large character base itself. So, and English has just 26 characters, and then there's like all other languages as well. So how do we deal with those different character sets? We'll be looking at that in detail in different class. But for now, we'll just look at very high level, simple example on how emojis can be encoded and decoded, just a very high level thing. And then some other methods like wrapping, like if you want the lines to be in a new line, and if you want to slice replace, how to extract substrings from the string, how we can just make a string repeat length of the strings, then how do we get a specific character from a string. Then this is again very useful. This cat operation is super useful. Like if you have columns, like you have first name, last name, then cat will merge these two columns and make a full name column. Or if you have like an address column where you want to combine all the address details into a single address column, like you have the city name, you have state name, then you have country name, then you have pin code, maybe the street name. You want to combine all these columns into a single column. That's also quite useful. You can add extra info as well with the concatenate method. Cat is concatenate. So again, I think that was really useful. That is really useful. And then date time operations. Basically, so if you have generally dates, if when you extract from the web, you will have them in string format, something like the year, then the month is something like this, and then you have the day, which is probably 19th, and then you have, if you are lucky, I mean, if that data has timestamp as well, then it will be like hours, which will be maybe 20 hours, maybe at 13th minute and 50th second, something like this. And this will be a string format. And extracting each and every component from this reliably can be a very hard thing from the strings. So which is why you have like convenient methods where you can perform, you can extract each and every component, like year, month, then date, right? And then you have hours, then minutes, then seconds. You can extract them individually from these date times using by calling the DT object, which is a date time object, and then we can do something like year, etc. We'll look at it. We'll look at this at the end, and how we can extract a particular which is what I discussed just now. And then you can change the date format as well. Suppose uh, this is like this date time format is kind of the US format, right? But in India, so this is like year, month and a day, or sometimes they even have year, day and month, right? But in India, we use like our format is date, month and year, right? So how we can convert that format to this format, all that we can do with this. And we can create custom formats as well, like if you just want date and month and we don't want year, we can do that as well. And then we'll look at NAT, which is the missing value in the date time field. So if you have already converted this column, the string column, into a date time column, then if there are any missing values, it will show NAT instead of NAN. So that's the agenda today. Let us begin. So I have my data here. So we'll be using the medical data. Let's do PD. So df PD dot read. Okay, before that we'll do the usual ceremony, which is pip install numpy, then pandas, which I already have, and we'll do import numpy as np and import pandas as pd. We did our imports, so we have our methods ready, so we have our packages ready. So now, yeah, let's read the data. So now df equal to pd dot read csv, and I'm going to check my medical data. I'll import the medical data. Let's check the head. So this is our medical data, and we'll have to do some. Now you see here, this is not desirable, so we'll do a melt. So df equal to pd dot melt, and rather df melt equal to pd dot melt. Let's see, what do we have? Let's check the documentation. Yeah, we'll keep these columns, id vars. I want my date, I want my drug name, I want the parameter as well, and the columns and rest of the columns I want to melt, right? So yeah, now since I rest of the columns I want to melt, now I'll give the names of the columns. The so this will be the this will be the what does it look like? It looks like time. So I'll call it time. The var name will be time. The column that will be melted, all the columns that will be melted, I'll call them as time, and then the value names I'll call them as readings. Timestamp, yeah, I guess timestamp is good. Now let's see what how our data looks like. Melt missing one required positional argument frame. Oh right, okay, we didn't pass the main thing, which is our data frame, which is our frame is df. So this is the thing we want to melt. So so as you can see, we have our timestamp column. All the rest of the columns got melted into this timestamp column, and all the others, the necessary values got replicated those many number of, as many column number of times the data frame got expanded. So if you look at the shape, the original DF is 18 rows and 15 columns, and DF melt shape is it will be like times 15, 18 times 15 to 16. So we have our this one ready. Now there is one more thing we have to do, which is a pivot, because we want our temperature and pressure to be separate columns. I don't want these to be as parameters. So I'll be converting this parameter column into, I'll be pivoting this parameter column into into two separate, into how many our categories there are, those many respective columns. Like, so this is basically from long to wide, we'll be converting the data. Let's see, what is the syntax here? It's I think pd.pivot. We can do pivot table as well, although it doesn't, we wouldn't be doing aggregations directly, so that's fine, I guess. df pivot equal to pd.pivot, I think. Yeah, we have to pass the data frame. Let's pass the melted data frame, because that's what we are trying to change. So the columns will be the parameter column, and because that's the column we want to convert, and then the index is basically the all the other rest of the columns that we want to keep them, so which is basically date. Then drug name, we want the drug name to be there. We want the timestamp as well, and then let's see, index, the values. Now the values are basically our readings. So values will be the readings column. Is it a value string object or list? So let's just pass a list for readings. So that's, these will be our readings column for temperature and this one pressure. So let us look at pivot data. So there you have it. Let's take some 30 of them. So for each drug we have the timestamps and the pressure and temperature values. Now as you can see, we have multi-level indexing going on here, multi-level columns as well. So let's do a reset. What was that reset? Was it reset? Is it reset columns or reset? Is it reset? Reset, I think indices. Index. Oh, it is okay. Reset index. That is reset index, and so we have the we have multi-level indexing for that. Okay. Let's now let's get rid of the parameter name, because we don't want that. Columns, first column we'll just assign to none. Wait. Pivot columns equal to think columns dot okay, so if you look at our columns, we have this one. So what we will do is we will simply straighten them. We'll do a join. We'll flatten the column, multi-level column. So we'll do a join on CNAME for CNAME in TF pivot dot columns. Now if we look pivot, we have our flattened list, and yeah, all right, so everything's good now. Let's do a CNAME dot lower. Tuple object has no, okay. Dot here then. Okay, so we have our data ready. So let's see. Okay, let's look at the first topic, which is none versus NaN. So basically, none is Python object, NaN is Pandas floating point, float 64 type. So if you look at the types of this one, it's a none type. But if you look at np.nan, so this is the NaN value. It is a float. So Pandas handles both none and NaN values simultaneously. It doesn't have a problem. It's just that performance wise, none is slower, while NaN is way quicker. That's the native data type kind of thing. So none has object overhead. So basically, yeah, none is basically slower, and you will only observe this if you have like large data sets, like maybe millions of rows. Otherwise, the performance is fairly similar. So if you see the behavior in numeric and non-numeric columns, like suppose let's create a data frame. So df equal to, okay, before that we create some, no, let's create some series, but let's call it S1 pd dot series, and if I create a none 134, right, and if I check the thing, if we see the data type, D type, is it D type or, okay, it's a series now. 1 second. Series. If we do S1 dot, is it S1 dot? Okay, so if we look at the thing, it says it's an object array, 3 non-null. There are 3 non-null, and the data type is object. So entries, 4 entries, 0 to 3 index range. So it considers all of the entire column or the entire array to be of object. Even if we remove the, suppose I remove the string type, and if we check this, even then okay, now since there are no strings involved, NumPy automatically considers none types as NaN. Like if we do the, suppose, let's see, null float 64. So you see the data type is float 64. Okay, let's go step by step. So the scenarios are none in numeric list, then none in non-numeric list, then you have NaN in numeric and NaN in non-numeric. So if you see here, this is the numeric scenario. We also checked the non-numeric scenario, right? So it became object. Now let us look at the same with np.nan. So this is the NaN in numeric scenario. If we look at this one, the data type is float 64, right? It has two non-nulls. Now if we add a string here, the data type became object. The behavior remains the same in both of the scenarios. But object arrays, the operations are slower. Now if we look at we looked at the data types as well. Now if we check the math behavior, suppose you try to do, let's take this one. So if I try to sum this, we get 35 as the sum, which is correct, 34 plus 1. But if we try to sum an object array, still it worked, because NumPy is Pandas is automatically considering none as it internally converts it into a float value, or rather considers a float value and then does the summation. However, if you look at the traditional arithmetic operations like 1 plus 45, it generally throws a type error. But if we do a np dot, it gracefully handles it as an NaN value, and this is let's see, yeah, so that's the math behavior for this one. So in general, that is how NumPy handles it. Pandas handles it. And then the memory use, obviously this has higher memory. The object arrays, those with none type have higher memory usage than NaN type. So if we do a none for this one, like do a df dot info, you'll see memory usage is 156 bytes. But if we do a np dot nan, let us see what it is, still the same. Okay. Okay, so I guess it's internally converting nuns to n, it's considering none types to nan. But if we do a, okay, actually that's not the correct example. Let me do this way. If I do this, it is 164 bytes, but if we do a none here, it is still 164. Okay, I think it is considering internally. Okay, I guess Pandas is optimizing internally. Probably it's the newer versions. Yeah, anyway, probably the newer versions. So as you can see, it is none and nan have complete compatibility. There's no difference there, and we can check null values using the np dot is null, and then if we pass the series, phi has no attribute, sorry, it's pd dot. So you see here we get a list of boolean values. So it's saying first is true, so which is exactly correct, and the same applies for nan as well. So if we do this and then we do this, it still considers that the nan is true. So we can handle, and is na and is null are both the same. They are essentially the same. We can check not null as well. So first is false because nan is null value. So we are saying nan is not null, which is false. So all others are 1 is not null, 34 is not null, strings object is not null. So these all are true. So these are two methods we can check null and not null. Then if you look at aggregations, we just looked at the aggregation, right? So if we do an S1, I think this will crash. This will throw an error because we have an object here. Now if we run it, we get 35. Generally these aggregations are faster using np.nan, but probably there is internal optimization going on. So I guess the time taken will essentially be the same, and we can only notice if there is any in the latest on large data sets. Like this is too small. If we look at time it, this took like 18.6 microseconds, and if we do a you see there is a slight increase. It's 19 microseconds. That's probably averaging due to CPU due to different cycles. Probably we can run it once again and we can verify. Okay, that took 20.9 microseconds. So as you can see, it slightly varies. We can check it once again with np.nan just to confirm. Okay, 24.3. So pretty much no difference. And we'll probably not see this in on smaller data sets. But then again, as you can see here, there's not much difference in both of them. Both of them are considered pretty much the same. Then if we look at equality check, EQUALITY check, so if we do a none equal to none, we get a true. But if we do a np.nan equal to np.nan, it will be false. So that's one difference we have to remember. Then if we look at the export representation, if suppose I have this data frame, let me take this one. I do a df equal to pd dot data frame, and I pass the series, and I think I have to set the column as well. LUMNS columns, call it strings. So if I export this to tf dot to CSV, let me see what is the file path. Okay, so the file path right buffer. So since I will be loading in this directory itself, I just have to give the name custom CSV, and I think that's sufficient for this one. There is just implementing object is passed. It should be okay. Separators, we have to give the separators. Since it is CSV, we'll give comma separated values. And yeah, so missing data representation, I think we don't need that for now, since we want to see empty values. Let's see the custom CSV. If you look at this one, okay, so if you look at the file that we downloaded, you will see here the first column is missing. So we can just look at it in the text edit. So you see here this is our index value, and the first value is basically missing. So that is how export works. So it will by default none and nan, and the behavior is the same for none and nan as well. So we can check for none as well. So you can see here, right, the thing becomes nan, and we can export the same. This will ultimately be the same. You can try that out yourself. Then yeah, so on string columns you will have by default you will have none itself, although let me check this one, np.nan, and I pass some string 1, string 2, and then I do a data frame here. If I do df.info, so you see here it still works. Even on strings you can have an nan. So all missing values by default, it's good to either convert them to nan just for performance sake, or just for consistency sake, or you can keep them as none as well, which is also not an issue, although internally there might be performance issues, because that will be generally it is said that none data type is slower than np.nan, which is the float value. Object types are slower than float types. We have seen that in the previous classes as well. So that is something to keep in mind. Then so coming to best practices, like I said, it is good to convert all the none values to nan by default. So you can do something like if we are on a series, then we'll do something like df. The column name is strs, and then we can do a replace all empty values with np.nan, right? And then if we load it, we will get nan. We can also set none here. That will still be considered as nan. So this is the it's probably the, yeah, I think this is probably the newer NumPy feature. Yeah, probably. Either way, you can use both of them to do that if you have missing values. Although by default, Pandas, when you import the data, it will by default consider missing values as nan. So like suppose we have our we just imported our CSV, right? Like suppose we just do a df read CSV. Let us read the custom CSV. You see here it considers the empty value as nan by default. So that's the default behavior. So that is that one. We can also, so suppose I have another, let me create a different data frame. df pd dot data frame. This is the NA values. So we can say that, like suppose I have names. Okay, can we use this one? Okay, so we have some NaN values. Let's see in our df pivot. Df pivot dot okay, let us load this data itself. I think that would be ideal. Let's call it df2. I will load this data, and if I suppose I have some empty strings or NA values, I can okay, I guess creating custom data frame is only ideal. So right now you see the original data has some NaN values, right? So what we can do is yeah, this is not useful. Okay, let me just create some. So let's say I have something like NA, I have some empty strings, I have some unknown, and I have maybe some names like maybe and then something like this. Now if when we load this data, suppose, okay, that is for read CSV, so then I have to export this one. Fine, I guess I can export this. Let me just create one more field. Age 21, 34, 22, 45, 33, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so we have our this one to CSV, and then I say people.csv, and then I do a comma separated value. What is it? Yeah, it is scp. Now we have our people CSV. So So let's first of all visualize the data frame here. So you see we have an empty value, we have an NA, we have an unknown, right? So this is our data frame. Let us import the data frame that import the CSV that we just exported. So we can do something like df3 pd.read CSV. I'll add the name, I'll pass the name CSV people.csv, and if we suppose I don't these are very hard to handle, right? I'll have to, suppose if I have unknowns in my columns, I'll have to check like I have to do operations like df3, then I have to check name, and then I'll have to say if column has names, so I'll have to do something like apply, then lambda x, then I will say if x equal to unknown, if x equal to unknown, I want the value to be set to NN, right? Else I pass it as it is, which is our original data frame. Let's look at our, let's call this df4. df4, this is our data frame 4. Now I will modify this. I'll modify this data frame 4 to like essentially I don't want strings which are like unknown or NA. So I'll have to do all this operations, like if x equal to unknown or x equal to NA, then I want all those to be replaced with np.nan, else I'll leave the columns as it is. So if we look at our data frame now, okay, I didn't assign df. So you see here that got and I can even check for null values, right? So we have set it empty here, so okay, I have to check or if x equal to. So you see here, this I have to write all this code to handle these kind of unknown or NA values. Now there is a default way of doing it. When we import the CSV, I can just set NA values, anything that looks like this or this or this. I want all of them to be considered as NaN values, not number values, or basically null values. Consider all those. Now if you see, it automatically set all those strings to NaN. If we do not give this, the default CSV that we have, that will give us, you see here there is unknown. Okay, why is this giving us okay, this is TF3. One second, we have read CSV, should have been NaN, right? What did we give? What did we export? NA. Exported NA, empty and unknown. Interesting. Okay, so I guess it's handling NA values by default. It shouldn't be the case, but Yeah, I guess it looks like it's handling NA values. Let me just export this once again. Let's call it people2.csv. And there it is, people2.csv. Now let's load excuse me. Okay, so it looks like it is considering NA values as NaN, which it should not, because that is not the behavior that we would want always, but okay. Yeah, that is a little strange, but yeah, it looks like it's handling NA values as NaN by default. So that's how you can, so as you can see here, using this argument, we can set something like, if I don't want this name as well, I want all the names that have Hitesh also to be considered as NaN. So I can do that as well. So you see here, all of these values are considered as NaN. So that's how you handle this part, or rather, that's how you handle default, or rather, that's how you can consider values as null values by default when you import CSV. Now, there are different ways of setting the entire data frame as NaN, because as you can see right now, the process is a little tedious, as you have to go, like you'll have to go over each and every feature, each and every column. To do it easily, let's see, let me just so let me just take this one again. We can handle null values in the entire data frame in a single piece of code, like in very quickly. There's one apply way, and then there is a vectorized way, which is a faster way. Let's see, let me just create some empty values here and here. Okay, so we have our data frame. Let's see what I have. My okay. So df4 invalid syntax. Okay, I guess I can set this. So we have some empty fields. So if I want to handle all of the things at once, like if I want to set all those values as NaN at once, so we can do something like df4 dot apply map. If you look at the documentation, it accepts a function. We do a lambda, and then let's see. If the value if pd dot is null, we will check if the value is something like if it is null or if x is empty, yeah, then what I'll do is I will rather, yeah, anyway, we want to set the value as pd dot null, so sorry, np dot nan. So if x is empty, then I do this, else I just return as it is, right? Let's check our data frame now. Data frame play map has been deprecated. Use data frame dot map instead. Data frame dot map. Okay, apply map. Okay, so there is a map function. Let me check. Function NA action. NA action none, ignore default none. If ignore, propagate NaN values without passing them to function. If x is empty, oh, okay. I guess I will have to assign it. Right, so there it is. So we can even handle it different way. So or we can say if x is NA or if x is unknown, I can set all of them to NaN by default. So you see here all the empty values are set to NaN. That's how you can do it on the entire data frame at once. You can handle the null values. There is another, and this is the slower way. See, it's just 5 values, so I'm not sure if there will be any impact on the time. But there is a faster vectorized way. We can do something like right, so we can do something like df. Okay, let me just reload this once again. So we have our data frame with the nulls, so we'll do something like df4. We can do pd dot mask. Look at the mask not found. df dot mask. Okay, it is df dot mask. Right, so we'll have to pass a condition where I want all of these values to be something else. So something like condition is false. In place, we can do an in place. We'll do an in place true so that it modifies the original array, and then we don't need access because we'll be doing it on the entire data frame, and then so the condition is essentially the same condition. condition replace access. Replace values where the condition is true. So right, so that's the where condition. So that's the where argument, where we will say set all those values to np.nan. The condition would be if let's see, how do we give the condition here? If df4 and I want to give me a moment. I think we have to pass the. I'm trying to get all the. Oh, it's other, not where. It's other. One second, let me just see it here. Okay. Okay, so the condition would be, since this is just like other vectorized operations where you set a Boolean array, right? So we do something like pd dot is na, and then we pass the entire data frame. It will give it a list of Boolean values. Like if we check this one, it will pass this data frame with appropriate values. One second, what is happening? df4. Okay. In this case, all are false because we don't have. Okay, let's do one thing. We'll do np.nan npnn and then np.nn. So we have these values. Now if we say I want to replace all these values with say unknown, right? Okay, before that let's check the mask. So you see here there are some true values which are missing. Those are the missing values. Now this will replace all those with with the unknown value, although it's not, this is an example, but that's one way to see it. Select setting an item of is deprecated and will raise an error in future. Okay, so what it's saying is in the future versions, we are checking if so if there is an incompatible data type. So like if we are setting float values in string columns, it will throw an error in the future versions. That is anyway, for now that is fine. We'll see value unknown has d type incompatible with float 64. Please cast to a compatible d type first. So okay. So what it is saying is the entire data frame, if we look at the data frame, the object type it is a object type data frame, and some columns have, one second, unknown has d type incompatible with float 64. Please explicitly cast to compatible d type first. Okay, so we are trying to replace float values with a string value, right? So that is why it's saying, that's why it's throwing a warning right now, saying in the future it won't be compatible. But yeah, I guess we can look at that later on, because the alternative would be we have to handle each column separately. Right now we are trying to check all of them at once, right? So what we can do is, if in that case we'll have to handle the map way. We'll have to check if column data type is of string or object, then ignore. Otherwise, if it is all any of the numeric types, then we can assign the particular numeric value. So in this case, for now, I think this is fine. We'll see what result it is. Let's look at the data frame right now, since we did apply it. As you can see, it set all the NaN values to unknown. Now, if we want to avoid the warning, so what we can do is, we'll say something like df. What I will do is, I'll have to extract columns which are of string data type alone, string and object data type. So something like call names equal to df4 d types, but select d types. There is a method. So select d types, it is basically returns a subset of data frame. Right, this thing is confusing me. So the signature is includes, we say include. So what data types to include? So let me I will include string and object data types. Does it give parameter values? So object data types, for numeric we do np.number to select strings with selection of d type strings to be excluded at least one of these parameters, right? So that's for include. And to select numeric, if we want to check numeric data types alone, we can set np.number or number, right? And for strings, you must use object data type. Yeah, for floats this is the one, for booleans this is the one, for ints this is the one. Okay, let us check this one. So I'm including all the object data types, and I want to extract the columns of object data types. Did we run the code, by the way, for this one? Let me just run it once again. So we have NANs, right? We have our null values. Now I will be operating on object columns. So let me check my object columns, which is basically one. So which is the name, right? So the it gave us the object column. Now we will operate on this object column. So we'll say something like df4. I will select all my columns, which is our object columns, and I will say df4. I will operate on all of these columns, and I'll do a replace. I want to replace all np.nan with all the null values with let's say unknown. Let's see what it does. So as you can see, it replaced in all the object columns. So suppose this actually does it on all the columns. So let's say I have another object column. I have two more object columns. Let's say name 2 and name 3. Right, I have essentially similar data, but let's call it Z K right, some random data we have. So we have 3 object columns right now. So if I run this code, it will still work on all the object columns. So this is super convenient. So you see here, all the NaN values got replaced with unknown. So this is one way to impute. Not exactly, yeah, I mean technical, the definition of impute is just to assign. So this is one way to impute the data. Now if we want to operate on the numeric columns, let's say I create age 2, age 3, and probably I have np.nan here, np.nan here. So you see our numeric columns, like if suppose I want to extract numeric columns, again from the documentation it says set it to number, right? If I select all the numeric columns, it properly identified age, age 2, age 3 as the numeric columns. Though it's setting data type as object. Interesting. Oh no, it's the, I guess it's the index data type. That's correct. Index data type is object because these are age 2, age 3. So the numeric data types, numeric data type columns are these 3, and then if we do a we'll have to give an appropriate value for that. So we'll say all the NaN values must be set to 0. So if I do that, as you can see here, it changed all the NaN values. You see here, all of them got set to 0. So that's how you can handle at a data frame level NaN values. You know, let's look at pitfalls, like what or rather what issues we'll face if you do this globally, like if you handle what is it, data imputation on the data frame level, if you handle all of the missing values or all that stuff as NaN, what happens is, although in this scenario, in this method, it's pretty safe. As you can see, the second method is pretty safe. The first method can have some issues. Let's use this one. Let me run this once again. So I have my NaN values in both numeric and object type columns, right? So if I do okay, so this example is slightly different. So let's see. What I'm trying to tell here is, if we set it to NaN for object type columns, it will generally cause some issues, but the newer version of NumPy, I think it will probably handle it properly. Let me just check once. So if I'm suppose trying to assign yeah, all that is unknown or NA or empty, I want to give it as NaN. So let's see what it will do. This looks good. So it changed all of them to NaN, and let me just check the data type of the object column. So we can do df4 name t type. Okay, so I guess O is object, is it? I guess it is. Okay, name 3. Do object and I try to replace all of them, not with zeros but with okay, so it is, yeah, O is object data type. Yeah, so it's handling it properly. I think both the methods are pretty good. There doesn't seem to be much issues. So that's how. So there is a. Yeah, this would probably cause issues in the previous version, but I guess it's pretty fine in the latest version, I guess. Let me check the Pandas if there's any change. pd dot version 2.2.2, I guess. No, I guess it's fine. Anyway, yeah, we look at the date issues, if there is any. At the end, we will see the NAT. What happens if we assign if suppose the date value is missing in that column, generally it transforms it to an NAT by default. But yeah, we'll see if there are any issues when we do a global like a data frame level imputation. Okay, so that is basically none versus NaN. I think that was extensive enough. I think that's sufficient. Now let's check at null values. How we can check how many null values, how to detect null values, although we already checked that. And we can check the count as well of how many values are missing. We take the same example. We have our data frame. Now I can do if df4 dot is na. This will give me list of boolean values, and if I do a sum, it will give me for each column how many missing values are there. So for name there are 2, which is nan 1 and 2. That's correct. So for age also there are 2, right? That's also correct. So that's how you see the count of each column. So like count of missing values in each column for the entire data frame. Now if I want to just check for an individual column, I can just pass the I can just do it on the series itself. So as you can see, it's giving us it's saying 2 of them are missing. Let's take something with 3 missing values. So age 2 has 3 missing values. So you see, it's giving us the count of the missing values. Again, is na and is null both are same. The functionality is exactly the same. So, and you can do this row wise and column wise. If you look at the documentation, well, let me no, not here. I guess I have to open this one. Okay, so what was I doing? Yeah, so df4 dot let me check the documentation for this. Is null. Okay, so the signature is basically that. What am I trying to do here? Yeah, so right. If you want to find the missing values at row level and at column level. So as you can see right now we are seeing at column level, but if I want to find missing values in a particular row, we can provide an access, if I'm not wrong. What access labels with missing values? Let me check. Don't think. So access 1 is horizontally the direction, and access 0 is vertically, right? So if I do a 1 unexpected keyword argument, okay. Turn a boolean same sized object indicating. Oh, that's I guess okay. I'm doing it on the data frame itself. Okay. It's mapped to false. Ask of boolean values. It also is null, not. Okay, I guess I guess that's for drop null values. Okay, I guess it is for drop null values. 1 second. Right. Okay. I guess that's for a that's for a different method. So you can yeah, you can only check column level null values. That is okay. I guess we can count right on the sum. 1 second. Sum. Yeah. It is on the sum. It's not on this. Is null. Sum has access. I guess 1 second. Iterable. Is it not the sum as well? Return the sum of a start value. So I guess we just have to provide access here. So as you can see, yeah, it does have access for some reason. Documentation is not showing here, but you can set an access, and for row 0 it says there are no null values. 1 second. Yeah, that's correct. These are all NAs, and row 2 has 4. 1, 2, 3 and 4. It's correct. Row 3 has 3 null values, and so on. So that's how you can check null at row level, null count at row level. Now let's jump to handling null values. How do we, now we have seen how to detect and how many null values exist. Now how do we handle these null values? We have already seen the in the first section itself, but we can see on column level how we can set how we can fill null values at column level using special methods like fill NA. The general rules though is basically, if you have, suppose, let me okay, so generally if the in the column you have data which is like less than 5% of the values are missing, then what we can do is we can generally delete them. If the count is greater than 10%, then there is significant then there will be like significant changes in the aggregations. Like suppose if we want to do aggregation on this column, and if less than 5% are missing, we can drop them. There won't be much impact on the aggregation. But if greater than 10% are missing, then there will be significant changes in this value. So we will try to impute these values using statistical techniques like using measures of central tendency like mean or median or mode. Generally, mean, median or mode, and like suppose and there if like almost 50% or greater than 50% values are missing in this column, then what we can do is we can drop the entire column. We can just delete the entire column, because that is going to give us wrong data anyway, right? So now let's look at the second scenario where like greater than 10% of the data is missing, right? What we can do, we can use mean, median, mode. We use mean if the data is kind of normally distributed. Like if there are not that many outliers, then we can use the mean of it, because if there are like lot of outliers, like suppose you have values like 10, 13, 11, 20, and then suddenly there is a 150 and 250, right? So you have 10 values that are around the range of 10, and then suddenly there are like 3-4 values that are beyond 100 and 200. If you take the mean of this, the mean will be quite large, which is not very good, or rather how do I put it, it gives wrong results, let's put it that way. It's the mean does not reflect the population, does not summarize the population properly. But if you take the median, which is the middle value, then you will get something like a 11 or something like that. Even though there are 150 and 250, it does not impact much. The mode is the most frequently occurring here. Like suppose there is a 10 and there is a 15. 15 is there 3 times. Then we can take 15. Generally, mode is used for categorical data. Like if you have like a list of genders, where you have a transaction list and you have a column that identifies each transaction with a particular gender, and if you have missing values in that gender column, then you can do a mode on that gender column to get a or rather to you can say to summarize the data properly. Let's just put it that way, to impute the data properly without too many deviations. And you can do median if there are too many outliers, like if there are like very large values that skew the data towards a particular side. You can use the median, like the middle value, to represent the data properly. So that's the basic theory. Let's see. We'll first look at how we can delete or fill the missing values. We'll take the same example. This is quite convenient. Let's see. Now I want to drop the missing values. I can do df dot drop na. Excuse me. If you look at this one, this has access. We won't be needing others. These are we can look at these arguments as and when we solve the problems. But we'll do an in place, because that is what we want to, or rather let's not do in place. It's not necessary to see the effect. So we'll do an axis, or rather, since the default axis is 0, which is vertically, let's see what the result will be. So you see here it dropped vertically, right? So it's checking all the row, it's going through each and every row. So it is seeing that. Let's see, how is it checking drop NA. So basically it removed all the rows with NaN values, right? So the first row doesn't have any NaN, it's Na only, it's a string, it's not an NaN, it's not a number. NaN is the null value, right? So it dropped all the rows with null values. Now if I give access as 1, it'll pretty much, I think it'll remove every column, it'll delete the entire table. You see here the entire table is gone because in every column we have null value. So what I'll do is, wait a second, NaN is, okay, so yeah, so what I'll do is I'll remove null values in the first column. Now if you run this, you will see the first column will remain because that's the column without the null values, and all others will be dropped. So that's how you can delete table, like delete rows and columns that have null values. Then we just discussed general rules for missing values. What we can do is we can check how we can do data imputation. We've checked removing nulls, right? Right, so let's go with the same example again. This is our data frame. Now I want to fill the missing values with a particular value. So I can do something like df.fillNA. Let's look at what the documentation says. Okay, it's df4. So it is saying we can give a value. The value can be a scalar, which is a single number value or something like that, and then you can pass a dictionary, you can pass a series, you can pass a data frame itself. Value to use to fill holes, basically empty values, right? And we can specify method as well, although this is slightly advanced and we won't be looking at this for now. We can specify the access as well. Again, we can do row level, column level. In place, again, we can modify the original array data frame itself if we set it to true. Yeah, the rest of them are not so important for now. Let us see. I'm going to fill it with let's say I'll fill it with 0. Age versus age 21, 34, 22. What is 22? Okay, it's behaving slightly strangely. Oh, okay. That is data frame. Yeah, we have to do it on df4. So as you can see here, okay, the first one is fine. So you see here, it replaced all the NaN values with 0.0. One thing you have to check here is this is by default float type, so it set it to 0.0. All the object type, it set it to 0. So that is how you can handle that. You can also set an object type, and as you can see, it converted it set the object value to a numeric column as well. And if we look at the column now, the column type will change to an object type. We can say df4 age 3 okay, it's still float. Interesting. Okay, df4 oh, okay, that is because we didn't do an in place. 1 second. df4 is, yeah, let's do an in place. So we did an in place, and then okay, we have our thing. Now if we check the data type, it is type object. Yep. So you see all of them got converted to object type. Now what else? Yeah, we can do this again vertically and horizontally, right? So let's do the filling vertically. The default is, okay, default access is none, so it's doing it everywhere. If I do access 0, which is vertically, so it goes row by row, it just did for everything. And if we do an access 1, still the same because it covered everything. Okay. Yeah, I guess that makes sense. That makes sense. It does not make much difference. Okay. Yeah, so that's basically how you do it. Now let's look at data imputation using particular values. So I can do df4. Now I want to impute this data with the mean. So I say I want to impute the age data, the age column, with the mean of fill na dot mean. Now if you look at our df4, you see it got filled with the mean of this value. So the mean of 21, 34, 45, 66. 21, 34, 45 and 66. So it's 166 by 1, 2, 3, 4, 5, 1, 2, 3, 4. So it filled it with 41.5. Right? 41.5, 41.5. That's how you fill the data. Now let's take some outliers here. So let's say I have age 10, age 11, age 15, and then all of a sudden I have 345, some old let's say an elf got into the list. So we run the thing, and then if we check the mean, you see the mean age is 95 now. That is quite unreasonable, right? So in scenarios like this, we have to use median to get to fill the data, rather to not corrupt the data. We can we should use median when there are extreme outliers like this. So now if we check 1 second, what is happening? Okay, I have to run it again. 1 second. ran it, I ran it. Now you see here the median value is 13 because um, 13 age how did it come to 13? One, two, three, four, five, 6. Okay, so it is 13 because so for even numbers, so these are we have 1, 2, 3, 4, 5, 6, right? So for even numbers, the middle value would be the average of these two. So it is basically, I think it is considering 11 plus 15, 26 by 2, which is 13, right? If there are odd number, then there would be a clear middle value, right? So in that case, it would consider something like a 15, or even, yeah, it would consider something like a 15 in case of a non-null value. Let's see. Let's look at mean here itself, median here itself. So median. This object has no median attribute. Okay, we'll do a pt dot series. So it got us a 11. So it took the lower value as the median. So we have 1, 2, 3, 4, and 5 items, right? Now if I have 6 items, then what it does is it gets us 13. So it does 15 plus 11, and it takes the mean of the middle two values. So that is how you can handle outliers. Now suppose I have let's say I want to fill categorical data. So I choose name 3 and I will fill it with the mode. Now if you see here, did it run? I guess because there are no repeating values, it's not yeah, I guess because there are no repeating values, let's suppose I give another NA here. And I run this now. So you see, now it filled it with, no, it still didn't. Name 3 tf4 name 3 dot mode. Interesting. Got the mode, I guess. Okay, when there are no repeating values, it will get all of them as unique. So here clearly there is one, but for some reason it's not. Fill in. Is there a condition? Method. Did I do in place? No, I am assigning it to that one. Okay, something is. I think something's missing here. Okay, so I guess it's because of the number of modes it gives. So if we look at the type of this one, it actually gives us a series. So the mode value, we want to just set one of them, right? So what we can do is, I think we just have to get the first value. And there you go, that set the NA into NA. So all I have to do is get the first value of the mode, the list of modes it's giving, and that filled it with NA. Since NA is the most missing values, in fact, let me change this. It's since it's slightly confusing. Let me just say it is the most repeated, most frequently occurring value. So now I change it to, you can see here, all the NaN values are changed to, or rather the NaN value got changed to hit, since this is the most frequently occurring value. And as you saw here before, if there are no repeated values, we will get a bunch of modes, right? We'll get a list of modes, so that's something to remember. We can choose any one of these values. In this case, if we want to impute, then we can just set it with maybe the third value, right? And we can set the missing value with this value. So fill NA x dot mode 3. Now if I do x, you can see here it's still NA. fill na x dot mode. Okay, I'm not doing it in place, right? So in place true, and there you go. You see here the missing value got replaced with the third value that we chose in the mode. So that is how you do data imputation. Now let's go to string methods. So we'll do case conversion. Again, this is pretty straightforward. I can show you in all these string methods. There are almost all of them are present in default Python language. So all we have to do is apply them on the string object of the series. So let's see. So if what we can do is we do a df4 dot we extract one of the columns. Let's say I'm going to extract the name column, right? Then I use the str object. So this is a string object. It's called the string methods object. So and on this I call the capitalize method. Suppose I do this, what you will see is or rather first let's look at the documentation. The documentation is pd.series. So as you can see, we are calling the string object on the series right? So we can access the documentation using pd.series.str.capitalize, and so what it says is it converts strings in the series to be capitalized. If we see the example, let me go here. So it has this series, and it has these methods, and one of them is capitalize, and what capitalize did is as you can see, it changed the first rather the first character of the word to the uppercase, and then rest of the characters are automatically set to lowercase. So suppose, I guess we have to take the right example. Let me take so I have something like this, right? If we do a capitalize, you see here it capitalized the first letter and then converted the rest of them to the lowercase. The same thing we can, the other one is lower. If we do a lower is nothing but it converts everything to lowercase. Pretty straightforward. Then we do a title case. The title case, okay, title case is interesting. We have to now if I run this one, so you see here, okay, I don't have a good enough example. 1 second. Okay, so if I run this, you see our second characters. Just observe the second words in this list. So if you see here, the title cases, it converts the first character of every word in that string to uppercase, and then the rest of the characters will be converted to lowercase. And uppercase again is pretty straightforward. It converts everything to the uppercase, all capital letters. That is basically case conversion. Let's look at removing or filtering characters. If we do a str dot lstrip, what does lstrip do? Let's look at the documentation. It basically strips white spaces or a set of specified characters from each string. So once again, we'll have to modify the list. In fact, let's just reduce our cognitive load. There's too many things here. So we want to do lstrip. So let's add some spaces here as well. Maybe here as well some. So we have some with these spaces, although you won't be seeing the spaces, but you can actually in the table, but you can access the data frame, and it does contain the spaces. So if you see here the name and get my first element, you see here the spaces exist, right? So now if we do an lstrip here and then access this again, okay, for some reason it didn't. Leading and trailing characters in series. Well, let's look at strip once before lstrip. Strip, if I do a strip and if I see, okay, it still didn't. That is strange. Strip white spaces including new lines or set of specified characters from each string in the from left side. That is for lstrip. If I do a strip, okay, 1 second. For some reason my laptop is really slow. Okay. Shouldn't be this slow, but okay. Okay, so we have okay, for some reason that is that, and more leading characters, string in series or index on left side replaces any non-strings in series with unknowns. If I do a strip, remove leading and trailing characters. So if I strip white spaces including new lines, specified characters from each string, I guess maybe I have to specify the thing. I thought by default there will be a okay, I guess I have to specify the character name. Strip. Okay, so let's say I want to remove all spaces. Now if I run this, still the same. Okay, it's still the same because okay, we're making the same mistake. Let me just reassign the, or rather I'm making the same mistake. Let me just reassign the values. Okay, there it is. It does work. Yeah, so that's how it is. Let me run this again so that we'll do a L strip. So you see we still have spaces here. Now if I think it will work without the character specification as well. Yeah, it still works. Now let's do an L strip. You see it removed all the spaces on the left, and then it still retained the spaces on the right. And R strip is exactly the opposite. It removes the spaces on the right and retains them on the left. Right? Pretty straightforward. And for the documentation, we can actually specify particular characters that we want to strip. Suppose I want to get rid of all the ends. Let's say I want to remove all the ends from this list. You see here it got rid of the n on the right side, and if we give a L strip, it will do the same. It will remove all. I think it will remove this and this as well, and this. It will remove probably 3 of them. Let's see. No, it didn't. Okay, it didn't because L strip is, it has to start from the beginning of the string. So if there was an n over here right at the start of the string, it would remove that. Let's see. Let me give something like this. In fact, okay, let me give a u here. I think it should start from the start of the string. Yeah, it should start from the start of the string. So if I give an n here, we have our string. Now if I get rid of, so we are doing an L strip here. So if I do this, you see here it got rid of all the n's at the start. If I do an R strip, it'll get rid of all the r's at the start. Let me run again, and if I do a strip completely, it will get rid of all the strips from the start and end. So that is basically left strip, right strip, and strip. You can specify the characters. So if you see here, for the document, specify the set of characters to be removed. All combinations of the set of characters will be stripped. If none, then white spaces are removed. So let's see, remove leading and trailing characters in series. See, leading and trailing. So that's the key here. It has to be at start and end of the string strictly. Something like, so if you see here the examples, it took out 1, 2 and 3. So this was the example. It had 1, 2 and 3 in each of the strings, right? And since we specified it, it got rid of all of them. So let's see. We have I will give n, I will give h, I will give an f, and I'll give a j. So this should strip all the first characters from our data frame. So run this. We have our now if we see, you see here it got rid of ends, it got rid of the h, it got rid of the, where is the f? Why did f not remove? Okay, it didn't remove f because see, the starting is filled with spaces. It's not starting character is not f, right? So obviously that didn't go, and it removed the j because the starting character is the j. So that is so that's what this method is about. Then let's look at searching. So that's what filtering was about. Now filtering or removing. Now let's look at searching. Okay, let's look at searching now. So we'll use the same data frame, or rather we'll use the smaller one, and so let's do a contains. So we'll get the series name, we'll access the object, string object, and contains is again pretty straightforward. We check if the string contains a particular set of characters or something like that. We will check str contains not found. Oh, sorry. Okay. dot series. So character sequence or regular expression. So if we set regex as true, we'll get a regular expression. I think we have something like that in here. Okay, no, I guess I'll have to cover that here itself. So pat is pattern, sequence or regular expression. So we check if the string contains this word or something like that. So something like simplest one would be if it contains, so you see here it came true. So this has the pattern, all others don't have. If we check HIT, this is true. If I check something in between, again this is true because ESH is here, ESH is also here. That's basically contains, but we can do something more complicated as well. We can do case sensitive, like case is true. If we do case true, and if I do an ESH, everything will be false. And if I try to search for HIT, everything will be false. Now if I set case false, if I set HIT, you see this one will hit true because it lowers all the characters in the string and then compares it with this pattern. That is basically contains, again pretty straightforward. Now we look at the regular expression one. So if I set regex true, still that is true because this pattern matches. Now what if I want to do something slightly complicated, which is search for a, see there is a word here, let's see what can we do. Now one thing, if you see, observe here, if I do this pattern, it gives true here because it found something here. Okay, wait. About VU. Okay, it's doing a full string search. Let's see. Starts with, ends with. Let's say I want to capture letters like N or K. So only the first one matched. Let's give another one, H. So you see, I want to match letters. I want to match all items which have either the letter N or K or H, right? So you see, this has K and N. This has H, which is the second one, so true, true. Third one does not have it. Fourth one has it, so that turned out to be true. This is a very simple example. We can do something complicated. Let's see, what else can we set here? Okay, let's do it this way. Let's say I want to get all the items that are numeric, right? So we can do something like only digits, that match only digits. I do a /d. Okay, these are strings, right? Fine. No, we can do it on this as well. 1 second. We are operating on strings, so yeah, there it is. True. So we are getting all the items that are only digits, right? And if we want items that are non-digits, then we do a capital D. So you see, these are all non-digits. The first and third are non-digits, so that is true. Just like this, we can play with these things. So suppose I want to get items which have spaces in them, suppose, and I do a, so you see here, first one is true and third one is also true. So that is how you can apply. For now, I'm not going to go too deep into regular expressions. That's something we'll cover in the Python section. So yeah, let's move on. That is how you do contains. Then string dot count. So let's see, what is count. Count. So count occurrences of pattern in each string of the series of index. So basically, so if I do a string dot count, I want to count the number of n's, suppose, in each of these, in each of the series. So you see here, there are 11 n's here. So 4, 5, 6, 7, 8, 9, 10, 11, right? So that's correct, and there are no n's in the other ones. So let's suppose I want to count the number of 2's. So there are 2 2's only in this one. Say I want to count the number of a's. There's only 3 a's in this one. Let's see, is there no common characters between these? I'll add a here. So you see here, there is 1 here and there's 3 here. There's 1 here, right? 1 and 3 here. So that's what count is. Nothing too fancy. Then ends with let's see, ends with, so takes in a pattern, right? Test if the end of each string element matches a pattern. So basically it checks the ends of each of these patterns. So suppose I do a pattern, let's keep a common pattern for this and this, suppose. Ends with n and n. So you see the first one is true and the third one is true because it ends with this n pattern. If I suppose give it a 4, 4, 5, 6, 4, 5, 6. Okay, I didn't run it. So you see here the second one is true, fourth one is true. So that's basically what ends with this. Let's do a find. Return lowest indices in each string in series. So basically it finds the first set of characters. Each of returned indices correspond to the position where the substring is fully contained between start and end, right? So basically what it's saying is, so if you look at the example, so it's saying find this one. It's finding the position of this character or that pattern in each of the strings. So suppose I am saying I want to find the pattern n. It's giving me position 0. That which it does not find returns -1. It found it at n here, position 0, that's correct. There is no n characters, n pattern here, so that's returning -1, and there is an n pattern at position 14. So if you see here, look at the characters, 1, 2, 3, 4, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So it found it exactly at the 14th character, this pattern, so that's correct, and there's no n pattern here, so it returned -1. So that is basically what find is. R find is, it finds from the end, from the right side. So find is from the left side, R find is from the right side. So you'll see here, it will get this one at a very large position. No, I guess find is general. Find is general. R find is only from the right. So if you see here, it found it at the 25th position. If you count here, there are 24 characters, and the 25th position is this one. Obviously, there's nothing here, so -1, -1 here as well, and it found at the 14th position. So this is particularly from the right alone. Now starts with, let's look at starts with. What is starts with? So starts with basically checks if this particular string starts with, test if start of each string matches the particular element. Again, pretty straightforward, right? It simply checks, yes, it starts with this pattern. You can play with it further. Now let's look at replacing and removing. Going to go a bit fast because there's a lot of methods. Basically remove prefix, right? Let's see, remove prefix. prefix. See what is the. So what it says is remove leading and trailing characters. Prefixes. So generally prefix is only considered to be on the left, but this thing does it on both sides. So if we say remove prefix, you'll see that that will get rid of start and end of these characters. Okay, it actually took only the left side, which is actually correct. That's what prefix means. Strange. Oh, okay. I was reading the wrong documentation. One sec. Remove a prefix from the object series. Yes, if the prefix is not present, the original string will be returned. Yeah, that's correct. So it only removes the prefix. Prefix is something that you have on the left. Suffix is something that you have on the right. So this actually removed correctly. Right, pretty straightforward. Nothing again, nothing too fancy here. It just removed this particular pattern of string from the left side of each of these strings, and remove suffix again same, it will do it on the right side. So you see here this n 3 set of n characters got removed. That which it could not find, it simply returns the string. Let's do a replace. Now replace has see what does replace have. So pattern, obviously it will take the pattern that we want, and rather pattern that we want to replace, and REPL is the replaced or the replace set of characters, which is the stuff that we want to replace with something like. So if I want to replace NNN with say AAA, you'll see here the pattern NNN got replaced with AAA. Right, same here as well, because that had the pattern NNN. Basically that is replaced, nothing too fancy. We can do a regex with this as well. I can do something like let's see, so I want to replace all the characters, or rather, one second. Okay, so the pattern here I will assign is, I want to replace all the space characters with zeros or maybe dots, right? Or maybe a single dot. So you see here it replaced all the spaces with dots. Here as well, since you see here these all spaces got replaced with dots. Let me put zeros so it will be clearer. So you see here, and I can do similar stuff with let's say I want to replace all the digits with zeros. Then you see here everything, all the digits got replaced with zeros. Something like that. You can use the regex. What do you call this? I think these are operators. Regex regular. Yeah, you can use all the regular expressions to do the replacing. Let's look at translate. Translate is slightly interesting. So if you look at the documentation, it says map all characters in the string through the given mapping table. So you see here we have to pass this table, we have to construct this table, and we have to pass the appropriate substitution. So basically you will this is quite useful if you are playing with ciphers or something like so cipher, so something like, let me show that. So suppose you have sent a message to your friend, something like maybe hello world or something like that. Now this is a top secret message and you don't want anybody to read it. So what you did was you did a simple scrambling, like you, not scrambling, you kind of, yeah, you scrambled the letters in such a way that only you know the pattern. So suppose you did something is called Caesar cipher. What you can do is you can shift the letters to the left or right by whatever length. So I can say let's see, there is one what is again, yeah, so let's say I shift this hello world by 3, right? So I bring D here, rather RLD, I'm shifting by 3 letters, right? So this comes first and H comes here, ELLO, and then space WOR. Not the best of things, but just to give you an example. So this has 3 items shifted. Rather, okay, actually this is not the best example. So wait, let's say okay, we'll take the same example. Let's just shorten it so that we don't have to spend too much time. So let's say you're sending the secret message called hello to your friend, and you don't want anybody to read this. What you do is you substitute each of these characters with a different character. So say you have a mapping. So H is mapped to E is mapped to B, L is mapped to C, and O is mapped to D. So this is your mapping. So your secret key now is, since H is A, B, C, C, D. That's your secret key, right? So this is your message. This is your encoded message. Now to decode this, your friend must have this mapping table. So so once your friend receives it, he will check the map. So A is H, so he will say, okay, that is H. B is E, C is L, so he maps that to L, and D is O. So that's how he decodes it. So you can do something similar in translate. Rather, translate allows you to have a handy substitution. Yeah, I think it's called substitution cipher. This is a substitution cipher. So we could do something like, yeah, let me just create the table. So we need to create the table first. So my table, so the mapping I can, so if we look at this documentation, right, so we don't have to do all this thing. We can do something simpler. I think we can just assign, say suppose I assigned let's see, all U's, all K's, and all N's will be mapped to X, Y, and Z. Now if I do a translate and I pass the table, since you see here translate accepts a table, right? Where is translate? See, it accepts a table, and the table is basically this one. There is a mapping here, so you see here N is mapped to N. The accented N is mapped to N, and the somewhat accented C is mapped to C. I don't know what this accenting is, but these are all, you see here there's a tick at the bottom, and there's a like a tilde at the top of the N. So these are all accented characters, and there's a map. There's an equivalent mapping to that. So we're doing something similar without the map, because I don't want to type all the map. This is a shorter way. Let's see what this does. So you see here, it replaced all n's. Here n is mapped to z. So it replaced all n's with z. And all of u, okay, since I gave lowercase u, let me give uppercase u. Okay, so you see all the u's got mapped. There's only one u anyway. All the u got mapped. The u got mapped with x, and the k. You see the k here. The k got mapped with y. So x, z, y. So this is like this is how you scramble the message. And to unscramble it, you'll have to do a reverse. So if you do this, then you can unscramble it. But anyway, I didn't assign it to the table, so I guess so let's just do it in Autophone. I don't want to change the table, but okay. So if I assign it, I have my df4. Now if I want to unscramble it, I do the same, and I shift the keys and values. And if I check my table again, I will have the original table back again. So that's what translate is about. Let's look at splitting and joining. Let me just get the original. Yeah, so we know split and join, right? So let me do the split first and then join later. So df4 is so basically split is I can split the string based on a particular delimiter. So something like look at the documentation. So you see pattern. You can obviously do regex here as well, and you can pass in a pattern. So I can pass, say I want to split at space. Series object has no attribute split. Oh, sorry, you have to access this on the string object. So you see here, it literally, so what it's returning is an array of strings after every split. So there are how many? There are 3 spaces, right? So it's split at 3 spaces. So let me just give 3 spaces so that it only gives me 3 items. So you see here, it split that into 3 items, the string. So after every space, it will cut the string and store it in the list. So that's basically what split is, and then we can do a join, which is basically you have to pass a delimiter. Okay, let me see, is there something else? That's the basic of split. We don't have to look at, yeah, regex. Again, we can do the same. You can play with the regex as well. We'll do a join. So string join, and then the separator, which is basically where we want the strings to join. If I suppose give the we reassign this. So I have my df4. Okay, so I have my df4. Now if I do now if I do the same with join, I want to join at not the spaces, but commas, right? And by the way, by default is, if I'm not wrong, it is comma separator default. Is there a default delimiter to use between list entries? Okay, no, there is no default. Okay, so we can say I want to join these strings using maybe using this pattern. So after every, so yeah, let me just run it. So you see here, every item is joined with this pattern. So I can even use a comma, and everything will be joined with a comma. What is happening? Why is it doing this? Okay. I reassigned it. Fine. 1 second. Let me just run it again. So now you see everything. It joins the entire, all the list items into a single string. That's basically join. Nothing too fancy there. That's split and join. Now let's look at regular expressions. These are, some of them are Pandas related. You won't find them in, or you might find them in Python as well, but yeah, we'll see. So basically, let me run this again. So extract. What is extract? Extract basically, if suppose I want to extract all the ends from these strings, I can just extract that particular pattern. Pretty straightforward. Say I give a pattern n here. Pattern contains no capture groups. Okay, so I guess this is particular to okay, so the pattern it is asking is extract capture groups in the regex pattern as columns in a data frame. So if we see here, a capture group is your brackets, no, not brackets, braces, the round braces. See, this is the capturing group. So suppose I have okay, so I have some random thing. So if I do a capturing group like this, you see here how many matches it got. We got like a ton of matches. That's not what we want. So if I do, like if I want to capture all the ends in a three character n, that is considered as a single group, and it returns that as a match, right? And that's a single group. So let's use the same example here. Since this is a regex, I will give. So you see here, it extracted that particular sequence of characters from each of these items. Let me put it in separate. This is a bit confusing. Okay, so I think that is much better. Right now, see, it got the ends from here, and it only captured it once, not all the. It does not extract all of them. It only extracts the first set of things it sees. It did not see anything here, so it gave an n. Suppose we do an extract all, then it will capture everything. Incompatible index of inserted column with frame index. Oh. Wait, right, correct, so I have to run it again. Incompatible index of inserted column with frame index. That is incorrect. EXTRACT all. Index of inserted column with frame index. What does that mean? Incompatible, the above exception was the direct cause of the following exception. Reindexed value dot reindex. You mean reindexed value? Let me do one thing. I think something is happening here. I run this. Okay. Right, so since this is extract all, you see it is converting the table into a multi-indexed multi-level indexed table, because in the first item itself you have two matches here. So that's why you see there are, for the first item which is 0, it got 2 matches, and the second one it got 1 match. Now if I add another one, now you'll see there'll be 5 of them. So it captures all the matches here. So you'll have to construct a new table. Basically that's what extract all does. Let's do a full match. Why do you think it gave false? It gave false because it's not a perfect match. So until it matches completely, it will not give it as true. So let me pass this. You see, then it gave true. A complete match. That's what a full match is. So the entire string has to match it. Only then it will consider it as a full match. Again, match is just a half version of this. You can let's say I give let me use the same example. So see here, this came true, this didn't come true. This match determine if each string starts with a match of regular expression. Extract matched groups. So okay, that I think this did not match this did not fall under the group. No, there is a group. This should also be true. str match E, false, true. Okay, so I guess from the start only, I guess. It only matches at the start. Starts with a match of regular expression. Okay, so this didn't match because it's at the end, it's not at the start, right? So there is a start here. Now if I add a start over here, now you will see that thing matches. So basically that's what a match is. Again, nothing too fancy. If we do a replace, again we saw, I don't know if we saw replace, but so replace has the replacing regex, and with I want to replace all ends with zeros. Pattern and replace. Okay, I guess it does not place each occurrence of pattern or regex in the series. Interesting. So if I have n okay, it does not accept groups, I guess. So we can do something like, if I want to replace all digits with zeros. Strange. Oh, it didn't, because we did not set the regex true, right? You see here, that worked. So if I want, let's say I want to replace all the digits with zeros, you see here it replaced all the digits with zeros. Again, pretty straightforward. Let's look at character tests. It should be pretty quick. So I want to check if a string is composed of alphanumeric characters. Right, basically alphanumeric is numbers, letters, and I don't think without any spaces. So I don't think there should be any spaces here. Yeah, is all num. So you see here the first one came false because it's not strictly alphanumeric, because there are spaces in that. Second one is true because there are numbers only, there are no spaces. Third one is false, you have spaces. Fourth one is true. So if I remove spaces here, now you will see this became true because it has letters, right? If I give special characters, like suppose I give these, that became false. So that is alphanumeric. Now if I check is alpha, it just checks for alphabets alone. All of them are false because again there are spaces. Spaces are not considered one, just part of alphanumeric or just alphabets. So you see it here, if I run this became true because this is only composed of alphabets. Again, is decimal is the kind of similar, just for numbers. So if I run this, you see that became true because these are just numbers. these are not, and if I add some numbers here, that will still not be considered because that becomes alphanumeric, and we're checking for numbers alone. Is lower checks if it is strictly lowercase. False, 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 because none of them are strictly lowercase. And if I do this, you see that became true because that alone is strictly lowercase. Is upper is again the exact opposite. I think you can play with it. Is space is something that you will see if it contains only spaces or not. So if I do an is space, everything will be false. If I change this to this, you'll see that came out true. So it checks if the field is just filled with spaces. Is title checks for title case. Again, all of them are false. Now if I change this to title, what is title case? Title, I think. Yeah, title cases, the first characters in every word must be uppercase and the rest should be lowercase. Now if I give a S here, that becomes false because this is not a strict title case, right? And if I give this lower, again it will be false. If I give this false, right? So strictly the first character must be uppercase. Then you will see this as true. So title case is that, yeah, you know what upper is. Now let's look at encoding and decoding. This is slightly interesting. I will take a separate class for this alone. Encoding and decoding is basically, just to roughly put it, encoding is is similar to what I discussed before on in the substitution cipher, the translate example, string dot translate. So encoding if we stick purely to the digital devices, encoding is basically you can say it's just a way of, it's a different representation which that particular medium understands. So suppose in this case, how do I put it? Databases accept a particular type of encoding because that's how they are meant to be stored in databases. Like computer memory has a particular way of storing, they can store in binary. Then there is bytes. They have bytes. They have byte arrays. Some of them accept byte arrays. Some of them accept hex values. Right. These are all different types of encodings, and to decode them is to decode them into, to put it in a crude way, human readable or another entity's readable format. So suppose one guy, to give you a real world examples, let's say one guy knows Japanese and I know Sanskrit or something, and if he has to communicate with me, he must know the word to word equivalent of how Japanese and Sanskrit translate, right? So I only understand in Sanskrit, he only understands in Japanese. So the Sanskrit's encoding to Japanese, how do I put it? Yeah, Sanskrit must be encoded to Japanese, and for me to understand the Japanese, I have to decode the message back to Sanskrit. So let me just show you an example. I will discuss this more elaborately in the class that I'll be taking on this one. suppose emojis are there. Emojis are again different from standard characters. Okay, so we have these emojis, right? So if we run this, and if I do a if I do an encode, if I give a character set, so if we look at encode, I will explain this one. So if it takes an encoding, so encode character string in the series or index using indicated encoding. So if I take the encoding as UTF-8. So this is the standard encoding that has the most coverage, you can say. This is like most widely used. If I do this, you will see the way these emojis got converted into byte format. So the result that the encode method gives is basically a byte object, right? If I want to decode this byte object, so this is you can say a database friendly. So you see here, this is B. There is a B prefix to this string. That means it's a byte object. It's not a string. It's a byte object. So if you look at the data type of this one, dot D type. Okay, it says one sec. You see, it's of type bytes. Each value that we have here is of type bytes. Each of these is a bytes object. Why do we need to do this? Because if you are doing web scraping or anything like that, if you are trying to clean data, generally you have data coming from different sources, right? It's not like only English. You will have you will have maybe text. You're maybe analyzing text messages. Maybe you are on Facebook and you are analyzing bunch of messenger messages and stuff. Right, so in those cases, you might not get the data in perfect emoji format. You might get something like this. So, in order to make sense of this kind of data, you must know like what type of encoding was used. There are again different types of encodings. There is UTF-8, which is the most common one. There is Latin, if I'm not wrong, Latin 1, which is an extension of ASCII. There is ASCII. All these letters, the common ones, are basically ASCII characters. So ASCII is the American Standard Code for Information Interchange. Basically, it's a representation of this character. So all these characters you see these are all ASCII characters, other than the periods and commas. And they have a particular range, like 0 to 120, if I'm not wrong. Standard ASCII is 127, if I'm not wrong. The extended ASCII is 256. 1 second. ASCII. This was. So if you see here, yeah, 120. There are 120, so 0 to 126, so basically 127 values. The extended ASCII is goes up to 255, basically 256 characters. Extended ASCII is the Latin encoding. Then there are others as well. Something like what else? There is UPC something which I don't remember. But these are like the uh, common encodings, or rather common, you could say, character sets. Yeah, and one of the features of ASCII and Latin is there is a one-to-one encoding, which means if you see the bytes, their bytes are exactly a match to their ASCII value. Again, I don't want to go too deep into this one, but let me just show you what I meant. So, if I have a excuse me. So, suppose I have a character H. If I do an encode, you see, I got the byte exactly H. There's a one-to-one mapping. But if I use any other character, like so let's say I take this one. This character, you see it's completely different. There are three, I think there are 3 bytes, right? So that is the thing about ASCII and extended ASCII. They have a one-to-one mapping with the encoding versus the underlying value. Now, if I want to, so let's take the same example. I will explain in detail in the upcoming class. But if I want to now get back the original string, I have to do something like, let me just reassign this. So my table is now modified. Right now, if I want to do a decode, then I do the same, but with I decode it with the same character set, and I get back my original string value. So yeah, that's a brief about this. There are different things like how you can extract, or rather how you can find the Unicode point for this emoji. So if you, again, there is something called points. There's like bunch of them. There's like Unicode is character set is like the ultimate character set, like it's the superset of all character sets. Every single possible character that exists on internet or online or anywhere is part of this character set. So this has everything in it, from Sanskrit to Japanese to Chinese, English obviously, and then all the special characters, all the backticks, all hashes, at symbols, parentheses, colons, question marks, all special characters, every possible character that you can think of, or if you have seen online, exists in this character set. And they have a different way of representing, and then there is a conversion back and forth from, like, how do we convert Unicode to the bytes and bytes to Unicode, back again, how do we convert bytes to binary, right? All this conversion stuff and everything we'll discuss in the next class. For now, I guess that's sufficient for encoding and decoding. Let's look at the other few methods, then we'll get into date time operations quickly. So cat, okay, so this is again super useful. let me just take, I guess I have to take a different example. Let me take names. Let's take first name. Just take two of them are sufficient. Then I'll do second, rather last name. If I do a concat is basically I'm merging, I'm joining two strings. In this case, I'm joining two strings of two different columns. So if I do a so if I add a different column called full name, I will do first name. So this one, okay, this one, how does this str.cat? Okay, so I do a first name dot str.cat. Let's look at the documentation once. So it's taking others. Others is basically another series, or you can even give a list. So I can provide it with the TF for my other column name, which is my last name. I can give even multiple columns as well, but you can pass in a list of series as well in this. Then what else? It's asking for a separator. Right, so separator, the default is like an empty string. So I can give a space here as separator. And what else? Join, yeah, this is unnecessary for now. Let's look at just these two. You see here, it combined the first name and last name into a single string. I can even give a list of my own custom names as well. I can say I want to join my first name with the first. So again, this list has to match the number of items present in the in this series, right? So I have to give two values now. Let's say zebra and potato, some random names. So you see here that appended these values next to each of these each of the items in that first column. So that's how you do concatenation. Let me do a get. Get is again simple. It gets us the position. Let's say I want to get the positioned value. I want to get the third value. So you see here, the third position is 0, 1, 2 and 3, which is H. That is correct. Again, same in this case as well. If I want to get the first item, you will see I get the first positioned item from this string. That is get length. Again, it gets the length of the list. Right, there are 7 characters in the first name. Right, so 0, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. Right, that's again straightforward. If I do a repeat, string methods repeat, missing one, required positional argument. Okay, what does repeat take? Okay, so you have to pass in the number of times you want this item to repeat. Suppose I want this to repeat 7 times. So you see here, it repeated the name Tej 7 times. Same for, it does this for every column. If I give 3, rather every record, every row, it repeats that same item for 3 times. Again, straightforward, nothing too fancy. Again, slice. We have seen slices like throughout all this lecture. I don't think I have to especially explain this one. Let me talk about slice replace. Slice replace. So if you see slice replace, it accepts similar. You see that just like slice, it takes in start and stop. There's no step in this one, but instead of step, it has a replace option. So what you want that start to stop string substring to be replaced with. So if I say I want the start to be 0, stop to be maybe the third character, I want to replace with hello. Let's just say that's my replace character. REPL. Start, stop. Now you see here, it replaced HIT with HELLO. Again, MIT, the first 3 characters, 0, 1 and 2, right? Stop, the stop is excluded, right? So 0, 1 and 2, so that got replaced with hello. Again, that's it. It's nothing complicated, pretty straightforward. If I want to replace the somewhere in between, I can do something like 3 to say 5. If you see here, 3, where is my third position? 0, 1, 2 and 3. So start is inclusive, right? 0, 1, 2 and 3. So from H, 2, 3 and 4. So HE got replaced with hello, because stop is excluded, right? The 5th position is excluded. So 3 and 4 got replaced with the word hello. What else? Wrap. Let's look at wrap. I think for wrap I need some longer text. Let's do a forum. Give me some text. So if I take this one, I'll get rid of this. We don't need this one. Let's just stick to one single. If I take this one, that's quite a long string, right? So what would we'll add this one as well. Maybe I'll remove this one. Don't remove this one from this. So these are 2 long strings, right? Now if I do a wrap on this, requires one positional argument width. So width, what width takes is, it takes in the length of the string where it has to divide or wrap this line. Let's say I want this to be divided after 5th line. So you see here, it adds this new line character, new line escape sequence. I think it is escape sequence. Yeah, so it's basically the new line /n. It adds /n after the 5th position. If I do a 6th position, it does that at the 6th position. If I do a 10th, it does that after the. Okay. I have to run it again. Now you see, is it 0, 1, 2, 3, 4? That's not the one. Oh, okay. 1 second. Full name, first name. One, two, three, four, five. What is happening for me? TF4 first name. Wait a second, let me check the app strings in series index at specified line width. So this method has the as default as text wrapper with maximum line width. Maximum line width. So wrap at 12, then it did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, this is correct. Line to be wrapped, another line to be wrapped. Okay. I think it has its own calculation, because if you see the first line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here it did it at the 10th character for some reason. The second one it did it at the 12th character. Maximum line width. Okay, now it did it at the third position, but I think for something greater than so 1, 2, 3, 4, 5, 6. So here also it did it correctly, but I think something greater than 10, it's not quite accepting. Okay, I think I will probably check the documentation in detail, because I don't think this is how it should behave. But yeah, we can see in the documentation as well, it's not quite accurate. Right here it's breaking at the 10th line, while here it's breaking at the 12th line. So yeah, we'll see in a future class. This is not that important, but still, yeah. So that's basically the idea. Is you wrap it at a particular character. Maybe it by default chooses to break at space, like if you see here as well, it broke at the space character, right? It chooses the nearest space character, I guess. I think that's what it is. If I give a greater width, suppose I give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I give it maybe a 15, you see here it shows this one. So I guess that's what it is. It chooses the nearest space or the appropriate place to break the line without breaking it in the middle of a character. It chooses the space as a appropriate nearest space as the appropriate place to break the line. Yeah, which is actually which is actually, which makes sense. I think that's the way it should be doing it. Yeah, I think that's what it is. Let's go to the next one. Finally, date time operations. So by default, when you are extracting data from the web, you will get string data. But to manipulate the string data of this date time, suppose you have something like so you get maybe a bunch of dates, like list of maybe DOB's date of births, right? They were born on 1993, in the maybe 5th month and 19th day, and then at a particular time, so suppose 17th hour, 53rd minute and 17th second, something like this. And you have bunch of dates like this. These are all in string format, right? And not only string format, there is no guarantee that everything will be in the correct format. Something you might have dates like Jan 15, 1998, or something like maybe the pattern here is like, if it's Indian, then 5, 12, 1973 or something like this. So to extract the data from these values consistently and correctly, you will have to convert this into a date time object, Pandas date time object, right? So that you can extract the year, day, date, hour, minute, second from this from each of these date values. So let's say I think I have to construct a new one. So I have my data frame here, date times, let's say something like I have 1993, it's 8th month, 19th day, and at 17th hour, 15th minute, 12th second, suppose something like this I have. This is 12th hour, 1st month, 1st second, says 79, and second month, 1st day. Yeah, let's take 2 of them. I think 2 of them are sufficient. Let's call it DOB, and I'll have a list of names. So this is my data frame. Right, so I have the names and date of birth. Now if we look at the info, the data types, both are of type objects. And if I want to extract information from this, it's quite tedious, right? From the date of birth, I have to do something like str dot something like extract, and then I'll have to perform some regex, and then maybe get the first 4 characters. All of that I have to do. Now, and that is only for the year. And of course, if they are all in different format, that's a whole different thing. Assuming all of them are in the same format, and I want to extract the year, date, time, whatever, um, what I can do is I can pass, or I can do that using a DT object. If you look at this one, excuse me, okay, it's df4. Can only use DT access with date time like values. Okay. Yeah. Correct. So that comes after we convert it to date time. So we have to do to date time. Wait, is it to? I think it is PD to date time. Right. So you see here, date time. The data type changed to date time 64. Previously, it was what was previously? It was simply object type. See, type of object. Now, when we do a to date time, it changed to the data type changed to date type 64. So all I have to do is assign this back to the original one, and then our table will have the new data type. Now if I want to access the, say, just the year value, I can do something like this, right? I use the DT accessor. It's called date time properties object, and on this object I call the year let's say the year method or year value, whatever that is. I get the year variable, and then through this I can access the years alone. If I want the month, I get the months. If I want the days, I get the days. If I want the hours, I get the hours. Same with minutes and even seconds as well, right? So basically that's how you handle date times. So that is the string to date time conversion. If I want to extract the date, this is how we extract the date, right? Now if I want to change the format of this date, suppose I don't like year, month, day, I want to have it as day, month, year, then I can do something like df4 dot dt dot strf, I think it is strf time, and we have several formatting options. So if I want to just get the so if I want the day, month, year, I do %d hyphen %m hyphen %y, and this will give me just the years. So if I do df4, so you see here that converted the formatting to day, month and year. If I want just the day and month alone, what's happening? Oh, okay, I changed it, so I have to run it again. Can only use, I have to convert as well, right. TOB to date time. So I get only day and month. There are several others, like if I want to change the format of the months, I can do something like day %b to get the full month name. Oh shit, okay. So you see here I got the 19th August, and that's the short form. If I want the full name, I'll do something like %B. That will give me the full name of the month. Then year. So here we have so if I want short form here, okay, I have to keep running this. You know what? Let me not use the. So if I want short form year, I will get. You see, that is the short form of the year. I want the full year form, then I use capital uppercase Y. And obviously, I can use slashes or anything in between to get my value, or rather my date. What else? So date, month, year. Of course, there's time as well. So we can do hours. Then you have percent, minutes is %M, uppercase M, and seconds is uppercase S. Right, so that's our time. And if I want AM, PM as well, I can do a what is that? %P. That gives me AM, PM. Now, if I want to so this is, if you notice, this is 24-hour clock. If I want to get it in a 12-hour clock, I'll just have to do %I. Then I'll get this in a 12-hour clock. 17 is 5 o'clock. Yeah, so that is so that's all there is to string conversions. We'll look at the things in detail later on for jumbled up date times. Let me just cover the last thing, which is NAT. Suppose I have a blank field. You see here, the date time automatically converts it to NAT. NAT is not a time. That's the null value. It automatically is handled. If I have some random gibberish as well, it's still no, it doesn't. Okay. So all other scenarios, it will throw an error. So if I have suppose if I have an np.nan, that is still handled, right? So it handles empty strings, it handles np.nan, and I think it will handle non values as well. So suppose I give and none should be handled because none is object. So you see, and none is also directly translated to NAT, which is the empty value, not a time value. And when we try to format it, we are doing a string format, right? So and we try to format it, it becomes NaN. Either way, all none, NaN, NAT, these are all interoperable. They are all compatible, so that's not that big of an issue. In fact, it's not an issue at all in these cases. So that is all there is to date times for now, for today. I hope it was clear, and I'll see you in the next one.